Let's go ahead and finish up our review for Test 11 that you'll be taking next week on Tuesday. Yesterday, we got through questions 1 through 15 with what you're going to see on your test. So let's go ahead and finish up today by looking from questions 16 down to 25, the different topics that you'll have to understand how to correctly do when it comes to your test. Make sure you do have your review list out so you can follow along with me and write down these different examples as we're talking through them. Also, make sure you have your circle out, as the next section that we'll be talking about also has to deal with our circle. Yesterday, we did the all questions where we had to do the plus 360N at the end of our final answer. And we also did our capital letter questions, which require one and only one answer. Our next section that you'll be talking with or working with on your test is questions 16 through 18, which are our lower letter trig questions. Let's work through a few of them together. So if I gave you the question 2 cosine theta is equal to root 3. Now on this section from question 16 down to 18, you'll see the same restriction that I have on the top right-hand corner, that your theta or your answer has to stay between 0 and 360 degrees. Remember when it came to these lowercase trig questions, you could have 2 final answers, and that's going to be the case on the questions that you'll be facing on the test. The first thing that you'll want to do on any of these questions is to make sure that your trig ratio is isolated. That is not the case on this question. I need to get rid of that 2 that's in the front, so I'm going to divide by 2. So now I have cosine theta is equal to square root 3 over 2. Now that the cosine is by itself, we go to our circle and we pick out the different angles that have a cosine, which remember is the x, that has the x being square root 3 over 2. I do notice that the cosine ratio is positive. Where was cosine positive on the Cartesian plane? The 2 quadrants were quadrants 1 as well as quadrant 4. Those are the 2 locations where I'm going to find my final answer, and I found them to be 30 degrees as well as 330 degrees. Those were the 2 angles where the x value in the ordered pair was square root 3 over 2. In this section, I do want to have you give your answer in degree format. Just because of that qualification, our theta, or our answer, does have to fall between 0 degrees and 360 degrees. Okay, so let's take a look at another question here. Let's do a tangent. If you had tangent theta plus square root 3 is equal to 0. Once again, the trig part needs to be by itself before you can do anything else. So I'm going to start out by subtracting square root 3. So I have tangent theta equals negative square root 3. Now that the ratio or the tangent part is by itself, we can go to our circle and pick out our final answers. Remember, the definition for tangent is y over x. We notice here that the tangent ratio is negative. Well, on the Cartesian plane, we had labeled during class where was tangent positive, and that was located in the first quadrant because everything was positive in the first, and it was also positive in the third. Well, if the positives are 1 and 3, well then where are the negatives? They're going to be 2 and 4. So I need to look into the second and the fourth quadrants in order to find the final answer. Now, tangent, we do have to do a little bit more thinking in order to come up with the final answer because the tangent definition was y over x. If I need my final answer to contain a square root 3 that is in the numerator, and that's all that you have, that means the y inside your ordered pair is where the square root 3 needs to be located. If you take a look at your circle, where are the ordered pairs that has the y as square root 3? It is 120 degrees as well as 300 degrees. Those are in the second and the fourth quadrant, so we know that we have the correct 2 answers when it comes to our tangent question. All right, the next thing that you'll be facing on your test here, again, is one of our lowercase questions, but these ones on numbers 19 and 20, how I labeled on your review sheet, they have a narrow restriction. The ones that we just went through is said my theta, or my answer, could fall between 0 and 360 degrees. Well, because it could fall between 0 and 360 degrees, we had 2 different answers, because there's 2 quadrants where things are positive, and there's 2 quadrants where things are negative. Well, now on this question, and this will be similar to what you'll see on number 19, the restriction that I'm going to use says the theta has to fall between 0 and 90 degrees. Well, where on the Cartesian plane am I at between 0 and 90 degrees is quadrant number 1, that top right-hand section on the Cartesian plane. So my answer needs to fall in quadrant number 1 and only quadrant number 1. If we take a look at the question, just like we did in the last two problems, we have to get the trig part by itself. So I'm going to start by dividing by 2, and I have sine theta is equal to 2 over 5. We know that sine is y in the Cartesian plane. If I look at quadrant number 1, however, none of the y's say 2 over 5. So how do I come up with my final answer on this question? I have to use my calculator, and this is where we use the inverse button to help us come up with our angle. So I'm going to type in sine inverse, our fraction 2 over 5, and on this section, I'm going to have you round to the nearest tenth. So that means I have one number to the right of my decimal point. So once I rounded, I came up with 23.6, and that would be my final answer for something like question 19. Now, question 20 is going to be the exact same problem as with regard to the 5 sine theta equals 2. So whatever one you did on 19 is the same question on 20, but notice what's different is the restriction. This time, the restriction for the theta is in between 90 degrees and 180 degrees. Where is that on the Cartesian plane? That's in quadrant number 2, and that's the top left-hand section on your problem. Now, you could start this question the exact same way. You would divide by 5, so it says sine theta equals 2 over 5, but you would have got the same answer from the last question if you would have typed this onto the calculator. So how do I take that answer of 23.6 and put it into this correct quadrant? I had to back up from 180 degrees. Remember, we talked about our reference angles. It was the distance from the closest x-axis. Well, the closest x-axis to our second quadrant, let me show you again on our paper, out here is our second quadrant. Well, what axis is the closest one? The one on the left, and that was 180 degrees. Well, to get to the second, I have to back up, and that's why I subtracted my previous answer of 23.6, and there's my final answer on this question, 156.4. Notice that angle 156.4 is in the second quadrant, and we know in the second quadrant sine is positive, and the ratio that we had here was positive 2 over 5, so my answer does make sense on this question. 2 more sections for us to walk through here to make sure we're understanding what we're doing on our test. The next section is dealing with our conditional probability. Remember, with conditional probability, something had to happen first before something else could happen. There was a limitation or a restriction of what could happen on this question. So let's work through this problem. We're looking for the probability that the first spinner stops on the number 2 and that the sum of my spinners is the number 6. Now, when it came to these conditional probability questions, what we did during class was we listed out all of the options. I would encourage you to do that as well when it comes to your test. The questions that you'll be answering here on numbers 21 and 22 will have the exact same 2 spinners that we're working with right now. You'll just be looking for a different scenario than what I'm showing you here on these 2 examples. So the first thing I want to happen is that the spinner lands on 2. Well, the second spinner can be anything. So what I did first is I listed out all my options. So the first column, the first spinner had to be the number 2. The second column are all of the options from the second spinner, 1, 2, 3, and 4. Well, the question is looking for sums. So next to my question, I listed all the sums. 2 plus 1 was 3, 2 plus 2 is 4, and so forth. Well, the question said I was looking for a sum of 6. Well, which one of those has a sum of 6? The one that I put the check mark by. So how do I come up with my final probability? Well, the first scenario, I wanted the number 2 on the first spinner. What is the probability that that spinner is going to stop on the number 2? It's 1 out of 4, because 1 out of the 4 sections says the number 2. The second condition, or the second limitation, says I need a sum of 6. Notice on the screen here, we wrote out 4 different sums. How many of those sums said 6? Just one of them. So my second fraction is also 1 out of 4. We're going to multiply those together to get our final answer for 1 out of 16. Let's do one more conditional probability question before we finish up with our radical problems today. Our last conditional probability will look like this. Find the probability that the first spinner lands on an odd number and the sum of the spinners is greater than the number 4. So again, I have two different things that I'm looking at here, but the first condition or the first thing has to happen, and then that limits what can happen the second time. That's why I have the condition. What is the first thing that's supposed to happen on this question? I need to land on an odd number. What are the odd numbers that I have in my first spinner? The numbers 1 and 3. The second spinner can land on anything, so we're going to list out all of the different options, and we need to keep in mind as we're listing these out, I'm looking for a sum that is bigger than the number 4. So on my first column, the number 1, that was one of the odd numbers that was on spinner number 1. The second column was all the different numbers I could get from spinner number 2. Well, those are my sums if I add those numbers together. Remember, I was looking for a sum greater than the number 4, so I only have one check mark that I can put into that first column, the one that had a sum of 5. Well, that's not the only scenario that we can have on this question because it said the first spinner just had to be odd. 1 is not the only odd number that you had on that first spinner. You also could have had the number 3. So there's my first column with all the number 3s. The second column could be anything from the numbers 1 through 4. Let's go ahead and take a look at their sums when I add them together. Again, remember, I'm looking for a sum greater than the number 4, so I have 3 check marks on the right-hand column. Now that I've listed out the different scenarios, let's go and take a look at the probability. Again, the first thing that I wanted to happen was I need to land on an odd number. Well, on that first spinner, there were 2 odd numbers out of the total of 4 sections. So my first probability is 2 out of 4. And if you wanted to write that as 1/2, that's perfectly fine. I'm just trying to show where all of the pieces came from here. On the screen up here, I have 8 different sums that are listed, 4 in the first column and 4 in the second column. How many of those sums met the requirement of greater than 4? I see 4 check marks. So 4 out of the 8 met the requirement. Again, you could reduce that down to 1/2, and I'll do that. So 1/2 times 1/2 gave me my final probability of 1/4. Okay, so make sure that you do list out your options. Don't just try to do it all in your head. If you can see the options, then I think you'll be able to come up with your final answer pretty easily. All right, last section, this is from questions 23 down through 25. These are the questions that we finished up with in lesson 70 with regard to our radicals. Question 23 will look very similar to this. My job is to solve for x, and in the instructions I wrote, don't forget to check your answer. Remember in this lesson, we talked about that idea of extraneous roots. Was there an answer that really didn't work in our question? So if I take a look at this question, and my job is to solve for the x. Well, the x is inside of the square root, so I need to get rid of that square root first. There's nothing on the outside of the square root, so I don't need to worry about that. So we're going to square both sides of our equation to get rid of the square root. The square and the square root cancel each other out, and I'm left with x minus 5 on the left-hand side, and then 14 squared gave me 196. To finish solving for x, I'm going to add 5, so x is equal to 201. Again, before I say that's my final answer, I want to plug it back in to make sure that it actually works. Putting 201 back in for x, that will say 201 minus 5, which is 196. The square root of 196 does equal 14, so I know that I have the correct answer on this question. All right, next question. If I had the square root of 6x plus 7 plus 3 equals 1. Notice on this question, different than we just did, there's something on the outside of the square root symbol. I need to go ahead and take care of that first before I do anything else. How do I take care of the plus 3? I'm going to subtract 3. So I would have the square root of 6x plus 7 equals negative 2. Now, if you notice right there, there's something wrong. You just said a square root was equal to a negative number. Square roots are never equal to negative numbers, so there is no solution on this question. If you didn't recognize that, well, you would keep working. You would square both sides, then it would say 6x plus 7 equals 4. You would have subtracted 7, so it would say 6x equals negative 3, and then divide by 6, so you would think that x is equal to a negative 1/2. However, if I check -1/2, 6 times -1/2 is -3. -3 plus 7 is 4. Well, the square root of 4 is 2, and 2 plus 3 does not equal 1. So I would have known right then my answer doesn't make sense, so I would have to cross that off. I didn't have any answer left, therefore there would be no solution on the question. So watch out for that. Square roots cannot equal negative numbers, so if you see that already, you know that there's no solution on the question. All right, one more square root question. The square root of 8x minus 15 is equal to the square root of 4x plus 5. This was the question that we finished up with in lesson 70 that had the multiple square roots, or the multiple any kind of roots. Both of them are square roots. They're already on opposite sides of the question, and that's what we had to do when we had two different square roots in our question. Start off the same way that you've done in the last two problems. To remove a square root, we're going to square. So now the left side says 8x minus 15 because they cancel each other out. The right side says 4x plus 5. As I started to solve for x, I got all my x's together first. So I subtracted my 4x, and now it says 4x minus 15 is equal to 5. Because I put my x's on the left, then my numbers need to come to the right. So now I have 4x is equal to 20 because I added my 15 over, then I divided by 4, and that tells me that x is equal to 5. Now, those steps could have been reversed. You could have added the 15 over first, then subtracted the 4x, and you would still end up with the same answer at the end of the question. Again, let's double check, does that answer actually work? If I put 5 back into the question, 8 times 5 is 40. 40 minus 15 is 25. The square root of 25 is 5. So let's see if we get the same thing on the right side. 4 times 5 is 20. 20 plus 5 is 25, and the square root of 25 also equals the number 5. I see the same thing on both sides of our question, so I know that my answer is correct. All right, so make sure you look over these topics, and then you should be ready to go for your test that you'll be taking on Tuesday next week.